Alright, what we're getting into next here is what we call slope. Now slope is very similar to what we've been doing with our rate of change. The only difference is it's just relating it more towards a graph, and the reason why we call it slope is because it's what's going to form that slope of a line that's going to make it look like it's either going up or heading diagonally down. And sometimes you'll refer to it as you'll hear it referred to as rise over run. So what I'm going to do real quick is I just want to talk a little about slope in the different forms that we're going to see it. If we're given points, a graph, a table, equation, all that different stuff, so we've seen it. First thing we need to look at is the formula. So first off, when we see slope, we're going to see it represented by the variable m, and our formula is y2 minus y1 over x2 minus x1. Now, it looks a little crazy, but really all this is our delta y over delta x, just like we did with rate of change earlier. I'm trying to see how do my y's change and how do my x's change, and what is that going to give me for my rate of change, which in turn would be my slope of the line. So first example we're going to look at is, what if we have some points like right here? Well, let's take my formula, and I can say my second y, so these points right here are my second set of points and my first set of points. That's what I'm going to use for y1, y2, and x1 and x2. So when I'm setting this up, I'm going to say negative 6 minus a negative, not negative 1, minus 3, my y2 and my y1, and I'm going to put that over 2 minus negative 1. Okay, so now I'm ready to do my math here. So when I do negative 6 minus 3, that's going to give me negative 9. When I do 2 minus a negative, that's my keep, switch, that's really going to be like adding a positive, and that's going to give me 3. So now I need to reduce this down, because slope has to be in its most reduced form. I can divide both of these by 3, and that would give me negative 3 over 1, or just negative 3. Now this negative 3 over 1 right here is important, because if I was looking at a graph, that could tell me that my line will go down 3 and right 1, and then down 3 and then right 1, and that would kind of give me my line going down in a graph. And we'll see that here in just a second when I do my graph example. Okay, so that's real quick if they give us 2 points. So let's look at our graph now. Okay, when I have my graph here, there's a couple ways that you can do this. We can set it out first off by pulling off points if I want to. So all it takes is 2 points, just like we had. So I can use this 0, 0 right here in the middle. And I can also use right here, I have 6, 1. Now, since it's really like delta y over delta x in our rate of change, what I can do is I can set this up just like if I was going to do a table here. My delta y is plus 1, my delta x is plus 6, so that means that my delta y over delta x, or what could be my slope, would be 1/6. Now if I tested this out just to show you the same way, if I do y2 minus y1 divided by x2 minus x1, that's going to give me 1/6 as well. So that's where you see it's really just the same thing as when we found our rate of change. Now to show you what I meant, this slope tells me I'm going up 1 and right 6, and here on the graph we can see I go up 1 unit and then 1, 2, 3, 4, 5, 6 to the right. The negatives, it means it's going to look like it's going down. The graph, if you see here from left to right, it kind of looks like I'm heading up. That's why we have a positive. If it were going down, that would be my negative. So there's a graph example. Let's look real quick at what would happen if I was looking at a table. Now, if I was looking at a table, it's going to be very similar to what we did earlier, or what we did on this example when I just... Okay, looking at our table example, here we go. So on a table, I'm going to set it up, since my slope is just like my delta y over delta x, that's what I'm going to look for here. So I'm going to look for my delta y's. I'm going to find one to find it, a second one to check it. This is plus 6 over here, plus 30 plus 30. So they're both the same, so that lets me know I'm only going to have to do it once here. So my delta y is plus 6, my delta x is plus 30. Now I need to reduce that. I can divide those both by 6, and that's going to give me a slope of 1/5. Now again, just to show you with our slope formula, I'll use these points here, with this first one being x and y2, and this second one being x and y1, just to kind of show you what that would look like. y2 is 12 minus y1 is 6. x2 is 60 minus x1, which is 30. And when we see that, I get my 6 over 30 again, which comes to 1/5. So this graph would go up 1 and it would go right 5. That's how I would kind of graph that graph. But that slope is going to be 1/5. So now, last one to look at, and this is our equations. This is probably the easiest one just because of the formula. We're going to start looking at things in what we call point slope formula. And point slope formula is noted as y equals mx plus b, where the m is our slope of the line. Now if you notice, this formula is this equation is already set up in that formula. Since slope and rate of change are pretty much the same thing, there is my slope right here. So when you have an equation, they give it to you. My slope would be -4. Now what this tells me is that I could also write this as -4 over 1 and not change my number, right? So that's going to tell me I would actually go down 4 and write 1 on a graph, and that's going to kind of give me a different look, because that has me going down 4, right 1, down 4, right 1. So that's going to give me a line that looks like it's sloping downwards right there. So that's a little bit about slope. We'll see it in different things, but if you already have a pretty good understanding of rate of change, you're going to be okay. If not, go back, check out the video on that, and that'll just give you an even more clear idea of how to find our slopes.